All right, let's talk about factoring. One of the keys to factoring is to consider where those factors come from. And when you think about it, if I'm going to multiply something like this, x plus 7 times x minus 3, I could stack them and multiply them just like I multiply anything. And I'll multiply this times this, and this times this, and then I go over one, multiply this times this times this, then I add up my results. And so in this case, negative 3 times 7 is negative 21. Negative 3 times x is negative 3x. Then I move over 1. X times 7 is 7x. X times x squared. And then I combine like terms. So I don't have any other x squared, so I've got the 1x squared. I've got a negative 3x and a 7x, so that is going to be 4x's. And I've got this minus 21, and then I add up my results. And this is what I get when I multiply these things. Well, factoring is taking it apart. I multiplied it together, so factoring, I'm trying to take it apart and figure out how to take it apart. And if you notice in this case, this negative 21 came from multiplying these numbers. This x squared came from multiplying these numbers. And then this middle term, this is kind of the tricky one. But what I did was I multiplied these, and then I added up the results. And that's where that 4x comes from. Well, notice in this case, negative 3 times 7 multiplies to be 21, but negative 3 plus 7 adds to be 4. So when I think about where did these numbers come from, they came from basically those two numbers, okay? Now, in algebra, we tend to do things, we don't tend to do things vertically, we tend to do it horizontally. And so, if you think about it, if I did this, if I did negative 3 times 7, negative 3 times x times 7, x times x squared, I'm going to end up with the same result. But one of the things you may notice here is that when I end up with my results here, and this is where that FOIL thing kind of comes in handy. Look what happens. I see that the x times the x, that gives me the x squared. The 7 and the negative 3, that gives me the last term, the negative 21. And then there's this inner and outer thing, and this is, I call this the double rainbow. This is 7x, this is negative 3x. I add those things together, and I get my 4x. So how does this relate to factoring? Well, if I know how they came together, maybe I can figure out how to take them apart. And more often than not, what I'm trying to do is find these things here to give me that, these things here to give me this last term, and then the right combination to figure out what this middle term is. So, having said that, let's look at some examples and some insights. Real quick, this is a solving quadratic equations by factoring. Let's see if I can get this a little bit bigger. There we go. So if you look at this, for example, this first one here, so I've got x squared minus 9x plus 18. If I think about what are two numbers that I can multiply to be 18, but would add to be negative 9. Let me restate this. What two numbers could I multiply to be a positive 18 and add to be a negative 9? Well, if I think about it, 3 and 6 would be 18. Negative 3 times negative 6 would give me the positive 18, would give me the negative 9x. So this one would factor if it factors. And by the way, not all of them will factor. I know that here's my x and x to be the x squared. Here I've got a minus 3 and a minus 6. So the negative 3, negative 6 gives me the positive 18. Those add together to give me the negative 9. Oh, but wait, I'm solving these. So this is equal to 0. Now, what would make that 0? Well, think about this. If I knew what x was, I would subtract 3 from it, and this would be a number. If I knew what x was, this would be subtract 6 from it, that would be a number. So I'm multiplying two numbers, and it'll be 0. Well, if either one of these numbers is 0, this is 0. So do you see that if x was 3, if x minus 3 was equal to 0, if x was 3, 3 minus 3 would be 0. That's going to be 0. So if x is 3 or if x is 6, this thing is 0. And you can plug those numbers in here and double check for yourself. Now, so all of these, so notice here, 4 times 1 would be 4. 4 plus 1 would be 5. I'm going to set, it's going to be equal to 0. I'm going to find out what makes those 0. Okay. In this one, in number 3, your instructor expects you to recognize that this is called the difference of two perfect squares. And the way this factors is, this is one of those things that you just kind of have to memorize. N times n would be n squared. 8 times 8 would be 64. But I'm going to do it this way. N plus 8, n minus 8. So when I see the difference of two perfect squares, I know that it's going to filter, or it's going to factor n plus something, n minus something, the same something. Because look, n times n, here's my n squared. 8 times negative 8 gives me the negative 64. But now when I do that double rainbow inside and outside thing, 8n minus 8n, that middle term went away. So if this is equal to 0, what makes that 0? If n is negative 8, or if n is 8. There's that. This one. Notice here in this one, I don't have all the terms. I'm missing, here I was missing the middle term, here I'm missing the last term. But I notice here, rule number 1, always, always, always factor out anything that's common. You're going to see this come up in several of these down here. If I factored out the b, I would have this. And if this is equal to 0, then do you see that if b was 0, that whole thing is 0? Or if b is negative 5, this is 0, the whole thing is 0. So always, rule number 1, always factor out what's common first. Okay? Now, this next problem. This time, the difference in this one is all these others had a 1 in the squared term. This one, they do not. So this one, I got 35n squared, 22n plus 3. But the one thing I do know is there's only one way to get 3. And that is, this has to be a 3 and this has to be a 1. The rest now is these, to get 35n squared, it could be 1 and 35, 2, 3, can it be 3? No, 4, 5, it could be 5 and 7, right? And so I look at all the numbers that I can multiply to get 35n, and those are my choices here. Now, this is really a guess and check kind of a chapter. It's all about guess and check. But the more that you do of these, you get better at guessing, right? And so if I do 5 and 7, if this is 5 and this is 7, that'd be 15 and 7, that'd be 22. So lucky guess, this is 7n, this is 5n. So that when I multiply, 3 times 5 is 15, plus 7 is 22. Here's my 3, here's my 35n squared. This is equal to 0. So now, to solve this, what I have to do is, so I've got 7n plus 3 and 5n plus 1 is equal to 0. If either one of these is 0, the whole thing is 0. So what makes this 7n plus 3, what would make that equal to 0? Well, that's when 7n would be negative 3. That means n would have to be negative 3/7. That's one of them. The other one, 5n plus 1, is equal to 0. That means 5n would have to be negative 1. That means n would have to be negative 1/5. And there are my two solutions. By the way, if you haven't noticed yet, if there's a 2 here, there's 2 solutions. If this was a 3, there would be 3 solutions. If this was a 4, there would be 4 solutions. So However many is here, that's how many answers I should expect to get. So, same way with this one. Notice this one, I only had the 1 and the 3. That's my only choices. Here I'm looking, my best bet here is I know there's only one way to get 7p squared. So this is where I'm going to start on this one. Now I've got to start looking at the factors here. The tricky part on this is negative, this is negative. So that means one of these has to be plus, the other one has to be minus. But if this one's minus, the other one's plus. What are my choices? 1 and 24, 2 and 12, 3 and 8, 4 and 6. Then I got to go 6 and 4, etc., etc. And I got to change all the signs. And so same thing on this one. This is a guess and check chapter. You may have to go through all of those options if you can. In this case, let's see. I'm going to guess 21. Let's see. If this was 3 and 8, it'd be 21 and 8. That's not enough. This was, what else have we got? 6 and 4, so 42 and 4. Yeah, 42 and 4. So if this is a 6 and this is a 4, so now which one is which, right? Well, I need more negatives, so the bigger one, this has got to be negative. This one has to be positive. Let's check my answer. 7p times p, that's 7p squared. 4 times negative 6, negative 24. I got negative 42 plus 4 gives me a negative 38. There we go. Oh, by the way, this is equal to 0. So to solve this, if 7p plus 4 is equal to 0, or if p minus 6 is equal to 0. So if p is 6, or if p is negative 4/7. There's my two answers for that problem. So hopefully you kind of see a pattern. What I'm trying to do is figure out what can I multiply to get back to here. Remember rule number 1, always factor out what's common. If you look at this one, if I factor it out of 6, this I can factor pretty quick. This is going to be 6 times what? K minus 4, K minus 3 is equal to 0. So if this is 0, that's got to be a 4. This is a 3. There's my two answers. And then also in some of the problems, they've got them mixed up like this. Here I got x squared is equal to 11x minus 28. It has to be equal to 0. I'm looking for factors that multiply to be 0. So what I could do is rewrite it. I'm going to subtract 11x from both sides, add 28 to both sides. Now I'm going to factor this. And same thing, x minus 7. X minus 4 equals 0. So x is either 7 or 4. There's my two answers. So hopefully this will be kind of a quickie review. You'll be able to look back on, maybe get some help with these other problems later when after we get off the phone or get out of class or whatever. Hope that helps. Talk to you later. Bye.